Let's do one example. Reflected ray is bisector of an angle formed between incident ray and surface. Find the angle of the incidence. Okay, so let me draw a so assume that this is a surface of reflection. Now we have a ray of light like this, and this is the normal line, and then this is the reflected ray. So so this is incident ray, reflected ray. Now what does the question says? The question says reflected ray is bisector, this is bisector, of an angle formed between incident ray and the surface. So this is the bisector, so this angle is equal to this angle. Let me show it by double line. Because this angle, we know that this angle is equal to this angle, and therefore this one must be equal to this one. And therefore we have three equal angles here. Three equal angles make 180, therefore each one will be 60, 60, 60, 60, and therefore half of them will be 30, 30 and 30. So find the angle of incidence. What is the angle of incidence? Angle of incidence is defined to be the angle between ray of incidence and normal line. So the angle of incidence is 30 degrees. The angle of incidence is this one, so it is 30 degrees. Another example, angle between incidence ray and surface is half of the angle of incidence. So let me draw another surface. Now a ray of light and normal line drawn perpendicular to the surface at the point of incidence, and of course a reflected ray of light. So this is the ray of incidence, the incident ray, this is reflected ray, and this is the normal line. So what is the question says? Angle between the incidence ray and surface, this one is half of the angle of incidence. So this is half of this. So if it is x, this is 2x. The angle between incidence ray and surface, this one x, is half of the angle of incidence, 2x. Find the angle. So x plus 2x is 90. Therefore x will be 30 degrees. And then find the angle between the incidence ray and the reflected ray. So 2x plus 2x will be 4x. So 4x is asked in this problem. This is the answer to this problem. Find the angle between the incidence ray and the reflected ray, which is 2x plus 2x, 4x. Okay, let's continue. Image in plane mirror. A plane mirror has a flat, smooth surface. Okay, image can be found by drawing some rays of light and their reflections. As you see, this is the object, this is reality. Above this surface is reality. This is our eyes. This is an object. So this is object. This is the image of this object. How can we find the image? By drawing some rays of light. This is a random ray of light drawn, and this is the normal line, this is the reflected line. We have applied the laws of reflection here, that angle of incidence equals the angle of reflection. Another ray of light is drawn here. This is the normal line or perpendicular line, and this is the ray of reflection. So we can see clearly that these rays are diverging and the reflected ones are also diverging. So if we continue them, the continued lines will be diverging. So they will diverge to a point like this. This image, this is the image of this object. We can draw some other lines, of course. For example, if a ray of line is drawn like this, what is the angle of incidence here? 0. And therefore the angle of reflection will be 0. Therefore it goes up. And then the continued line makes it, the continued line, a dashed line would be like this. So all of these continuation converge to a single point. This single point is the image of this object. So we can easily find the image of an object in plane mirror. What are the properties of image in plane mirror? It is virtual, which means it cannot be captured on a screen. So this is object, this is mirror, this is the image. So the image in a plane mirror is virtual, which means it cannot be captured on a screen. Same size as the object. So if the object is 1 meter, the image is 1 meter. H0 is equal to H of object is equal to H of image. Height of the image. Okay, laterally inverted, left and right or reverse. For example, if a person stands in front of a mirror and raises his right hand, the image raises her left hand. So it is called left-right reversal or laterally inverted image. Same distance behind the mirror as the object in front. So for example, this distance of BC is equal to distance of CD. So distance of object to mirror is equal to distance of image to the mirror. Equidistance. Upright. The image stands upright like the object. We'll see in the upcoming sessions about spherical mirrors. That's in the spherical mirrors, sometimes the image will be inverted, which means, for example, if the image is upright like this, the image is like this, inverted. This is called inverted, this is called upright. So if we stand in front of a mirror, we see ourselves upright and directly, not upside down. Okay, so these 5 are the properties of image in plane mirror. Okay,